Hi guys, good morning. In this video, I will be presenting to you about solving word problems involving logarithmic functions. This is just related to my previous video about solving word problems involving exponential function. So for the lesson objective, at the end of this video, you should be able to solve problems involving logarithmic functions. For the prerequisite skills, number one, solving word problems involving exponential functions because as I've said, exponential and logarithmic are just inverse functions. Number two, solving logarithmic equations and logarithmic inequalities. Number three, evaluating functions. Let's proceed directly to our examples. For example number one, a medical technologist observes that an ample number of coronavirus destroyed 50 cells of a COVID-19 patient. The number doubled after an hour. If the function c of t equals 50 times 10 raised to 0.4t illustrate the situation. We find the number of cells destroyed after 6 hours. And number 2, after how many hours the number of cells destroyed reached 500,000. So we will solve first number 1. As you have observed in the problem, we are already given the function which is c of t is equal to 50 times 10 raised to 0.4t. In this case, let C of t as the number of cells destroyed after 6 hours. Problem number 1, we are to solve for the number of cells destroyed after 6 hours. Therefore, our t here is denoted as the number of hours. Using this function, we can substitute our t, which is 6, to the function, in this case 0.4t. So instead of writing t here, we need to change this one with 6. So we copy c of t is now becomes c of 6 because our t is 6, that is 6 hours, is equal to the 50 times the 10 raised to 0.4 times the number of hours is 6. Then we simplify, multiply 0.4 times 6, that would give us 2.4. By using a calculator, we need to raise 10 raised to 2.4, which is approximately equal to 251.19. And we multiply this number to 50, so that would give us C of 6 is equal to 12,559.5, or out of the whole number, that would give us 12,560. So this is the total number of cells destroyed after 6 hours. Given this function, C of t equals 50 times 10 raised to 0.4t. As you have observed, problem number 1 did not include the concept of logarithmic function. Just simply solve the problem using the concept of exponential function. Let's proceed to problem number 2. After how many hours that the number of cells destroyed will reach 500,000? Using the same function, we will let C of t as the number of cells destroyed after t hours, and of course the t as the number of time in hours. Since we are given the number of cells destroyed after t hours, so this time we are given the number of cells, but we are to find the number of hours. So this time we are given the C of t. Problem number 1, we are given the t. We need to solve for the number of cells destroyed after an hour, after several hours. This time, we are to solve for the time, and we are given the number of cells destroyed after the hour. So, to solve for the problem, we need to substitute 500,000 to the C of t. So that becomes 500,000 equals, instead of writing C of t here, we write 500,000 equals 50 times 10 raised to 0.4t. This time we need to solve for t. Now, divide both sides of the equation by 50 to eliminate 50 here. Cancel out the 50 and we divide 500,000 by 50. That would give us 10,000. Equals what remains on this side of the equation will be 10 raised to 0.4t. We can just simply solve this problem by just expressing 10,000 to the base 10. So we can have 10 raised to 4. 10 raised to 4 is 10,000. Or we can change this one to logarithmic form, or we can, since this is base 10, we can just get log of 10,000 directly by using your calculator. So if we have the base 10, we can just simply write in your calculator log of 10,000 then equals if we have the base 10. If this is not a base 10, so it's another story. Okay, so let's proceed. In this case, I use log of 10. I get the log of 10,000 since base 10. Log of 10,000 is equal to 0.4t. So the log of 10,000 is equal to 4, which is equal to 0.4t. Then to eliminate, since we are to solve for t here, we eliminate the 0.4. So we divide both sides by 0.4. We cancel out 0.4. What remains here is 4 over 0.4, which is equal to 10. So therefore, the number of cells destroyed will reach 500,000 after 10 hours. So the number of cells destroyed will reach 500,000 after 10 hours. Let's proceed to example number 2. This time we will talk of population. The approximate world population is about 7.8 billion in 2020. The population increases at 1.1% per year. So number 1, we need to find the total world population for the year 2025. Number 2, in what year the population will double. So we'll solve problem number 1. Problem number 1 can be solved by just simply using the exponential function. So we use the function y equals a times b raised to x. Wherein our y as the total number of population in x years, then a as the world population in 2020, so the initial value of 7.8, and we let b as the rate of increase. Since this is increasing, so this is an example of exponential growth. So if this is exponential growth, our rate can be written as 1 plus the rate 1.1% per year in decimal is 0.011, which is equal to 1.011. So we will be using this value in our function. And of course, we let x as the number of years. So for the given, of course, we need to solve for the total population in x years, this time in the year 2025. So we need to solve y, that is a known. Then our initial value in the year 2020 is 7.8 billion. And our rate is 1.011. And of course, the number of years is 5. How did we get 5? That's the number of years in between 2020 to 2025. So 2021, 2022, 2023, 2024, and 2025. So to solve for the problem, we need to substitute this given to the function. So we will have y equals a, which is 7.8, times our b, which is 1.011, and raised to our x, the number of years is 5. Now this time we use a calculator. Raise 1.011 raised to 5. It approximately give us the 7.8 copy. Then 1.011 raised to 5 is approximately 1.0562. That's why I use approximate symbol here. Then we will multiply this number to 7.8. So approximately that would give us 8.238 billion. So therefore, the total world population for the year 2025 will be 8.238 billion approximate. Now, for this problem, as you have observed, we just simply use exponential function. We did not use logarithmic function. But for problem number 2, we will have the same problem. In how many years that the population will double? So solution number 2. We use the same function, y equals a times b raised to x. We let y as the total world population in x years, let a as the world population in 2020, and b as the rate of increase, the same 1.011, and of course x as the number of years. Now we have to take note that the population will double. In how many years that the population will double? So take note, double, if we will be talking of double, initial value times 2. So for the given, for y, since we are given the initial value of 7.8, so we need to multiply that by 2 to make to double 7.8, so that gives us 15.6. Since we are to solve for the number of years, so that's why we have let x as the number of years, so therefore we will be using, or we will be solving for the number of years, which is the x. So the initial value is 7.8, and of course our rate is 1.011, and our x is unknown, that is the number of years. So that's the question, how many years that the population will double. Okay, so substitute this problem to the function. So y equals 8 times b raised to x. For y is 15.6. This time, we will not be using 7.8 because the number will double after how many years. We just don't know how many years. Okay, so 15.6 equals the initial value, 7.8 times b, which is 1.011, raised to the number of years, which is the x. We need to solve for x. This time, we need to eliminate the 7.8. We divide both sides by 7.8, cancel 7.8, we divide 15.6 divided by 7.8. So what remains here is 15.6 divided by 7.8 is 2 is equal to, cancel 7.8, so what remains is 1.011 raised to x. So this time, we cannot use exponential here because they don't have the same base, and there is no other way except to use logarithms here. Cannot express 1.011 to the base 2 or 2 to the base 1.011. Therefore, we have no other choice but to use logarithmic function. There are two ways in solving this one using logarithmic. Number one, we can change this one to logarithmic form, where we just simply divide log of 2 divided by log of 1.011. So this will give us, we use the second choice, log of 2 divided by log of 1.011. Using a calculator, log of 2 is approximately equal to 0.3010. Then, log of 1.011 is equal to approximately equal to 0.00475. We divide these numbers here, we will have x as the number of years is approximately equal to 63.4 years. So that means the world population will double in 63.4 years. Number of population will reach 15.6 billion after 63.4 years at a rate of 1.1 per year, assuming that the rate is constant. I hope you have learned something. Don't forget to subscribe, like, and share. And thank you, and God bless.